So students, we are doing NCERT exercises, and this is exercise 7.13, page number 179. So this child stands at the center of the turntable with his arms stretched out, and the turntable is set rotating with angular speed of 40 revolution per minute. Now how much is the speed, angular speed? How much will this angular speed if the child folds his arms and thereby reducing the moment of inertia to 2/3 times the initial value. So 1/3 times the initial inertia is reduced, only left 2/3 times. And second part, we have to find the ratio of the kinetic energy. So by the principle of conservation of angular momentum, so what are the conditions that are there for the principle of conservation of angular momentum? So we know that F is equals to dp by dt in linear motion, and similarly here in rotational motion, torque is equals to dl by dt. So if net external force is 0, then P is conserved. Similarly here, if tau is 0, net external torque is 0, then L is conserved, means the initial angular momentum, so this is the angular momentum L of the system, is conserved, means initial. This means that, so here the principle of conservation of momentum, because there is no air friction, no turntable also rotates without any friction, so this tau is equals to 0 here. So initial momentum is equals to final momentum. So initial momentum of the system L1 is equals to final momentum of the system L2. So now what is L1? So like P is equals to mv. Similarly here we have L is equals to I, and for V I have omega. So I omega. So I1 omega 1 is equals to I2 omega 2. Very important concept, students. Now let me tell you something very, very important. Okay. So what's that? Something which is very, very important. See, in physics, we have these formulas, okay, like this, and so you see I'm writing these formulas. See, L is a vector, so I can, and here I and omega, so here omega is also vector. So scalar, this is scalar, so scalar into vector is vector. Okay, here also scalar into vector is vector. I will discuss more about it, these formulas which is very important. So I1 omega 1 is equals to, just like we have P1 is equals to P2 gun recoils, and M1 V1 is equals to M2 V2. So similarly here, so this was in linear motion and this is in rotational motion. Okay. Now we know the value of omega 1. Yes, we know the value of I1 by I2 is 3/2, or I2 by I1 is 2/3. So omega 1 is equals to I2 by I1 into omega 2. Okay. Okay, we have to find the value of omega 2 actually. Okay. So omega 1 is equals to omega, that's 2/3 omega 2. So we can even directly write, so here omega 2 is equals to 3 by 2, so this is 3 by 2 into omega 1. So what is omega 1? 3 by 2 into omega 1 is given to us, that is 40 rpm. So this comes out to be 60. Is everything okay?
The 2 by 5 omega.
Yes.
The 2 by 5 आएगा 2 by 3.
2 by 3 नहीं है given है क्वेश्चन, सॉरी क्वेश्चन में 2 by 5 है. ओके yes, it's 2 by 5. okay, so it's 2 by 5 students. So just be alert, okay, keep on cross checking the things. So this is 5 by 2, and this will be 5 by 2, so this is 100 rpm. So always check the answers from the back, okay, have a habit of checking the answers from the back of the NCERT. Now second part, B part of this question, kinetic energy, ratio of kinetic energy. So K2 by K1, that's equals to half I1 omega 1 square, so I can write it as omega 1 into omega 1, and that is I2 omega 2 into omega 2. Now here you can see that I1 omega 1 is equals to I2 omega 2. So half cancels, I1 omega, this also cancels out, because I1 omega 1 is equals to I2 omega 2, right? The principle of conservation of angular momentum. So we are left with only omega 1 upon omega 2. What is omega 1? That is 40 rpm. And what is omega 2? That is 100 rpm. So this comes out to be 2 by 5. So it means that K2 is equals to so the new
Sir, 100 rpm upon 40
sorry,
rpm.
yes, good. So
Omega 2 upon
omega 2 is,
omega 1.
here I am writing 2 and I am writing the formula for 1. Good. So here I will have 2 and here I will have 1. So it's omega 2 upon omega 1. So it's 100 rpm upon 40 rpm, and this comes out to be 5 by 2. So K is equals to 5 by 2 K1, and this means K2 is equals to 2.5 K1. So kinetic energy is increased by 2.5 times. So what does this mean? So as inertia is reduced, why inertia is reduced? Because here the mass was much away from the axis of rotation, and here the mass is near to the axis of the rotation. So distribution of mass is near to the axis, so that is why moment of inertia is decreased, and as moment of inertia is decreased, it is easy, rotational motion, it is easy to rotate as the inertia is lesser. So that is why you can see that the angular velocity is increased, and as the angular velocity increased, definitely kinetic energy is also increased. So kinetic energy also increased by 2.5 times. So I hope you have understood this question. Okay, next exercise. Seven 7.14. So how have we accounted for the increase in kinetic energy? Yes, so increase in kinetic energy is the reason is also means you should always read the reasons written at the back. The child uses his, so from where he gets because energy is conserved. Energy is conserved. So for closed system, energy is conserved and P is also conserved. So for isolated system, we have discussed it many times, students. for closed system, right? So these two are fundamental conservation laws. Energy is conserved and momentum is conserved for the isolated system. Means no particle is coming out or going out of the system. That's the meaning of closed system. And isolated system means net external force acting on it is 0, and closed means no entry or exit. Okay, so E is conserved. So E is conserved means, so how has the kinetic energy increased? So the child uses his internal energy to increase his rotational kinetic energy. So internal energy of child transformed to kinetic energy, rotational kinetic energy. Okay, now next exercise 7.14. So students, this is same as we have example 7.15, which is on page 171 in your NCERT. So open your NCERT books. Page 171. So in that question, which is 7.15 example 7.15 on page 171 in the NCERT. So there it was a wheel, okay, and here you have a cylinder, okay. So you have a cylinder over here. So something like this is the rope that is there on the cylinder, and of course it is fixed. This is the axis of rotation. So there you had a wheel and here you have a cylinder, okay. Now you have a rope of negligible mass that is wound around a hollow cylinder of mass 3 kg. So what is the mass of this cylinder? That is equals to 3 kg. And radius r, this r is equals to 40 centimeter, that is equals to 0.4 meters. And what is the angular acceleration of the cylinder? So angular acceleration alpha, if the rope is pulled with the force of, so force applied is 30 Newton. And what is the linear acceleration of the rope? And assume there is no slipping. So what is so we have to calculate alpha. So how many formulas of alpha do we have? Like how many formulas of A we have? So like you have F is equals to m into A. So in rotational motion we have tau is equals to I into alpha. So I need to find tau and I need to find moment of inertia. So what is the moment of inertia of hollow cylinder? I know the moment of inertia of the hollow cylinder, that is equals to mr square. For solid it is mr square by 2, right? This is from table 7.1. So now I know this I, but what about tau? So I need to calculate tau also, then only I will find alpha is equals to tau upon I, okay. So what is tau? or you can write this as equation of tau. Tau is by definition that is equals to r into f. So that's r into f. This r is the perpendicular distance between the, like here, this is the the view from this side, and the view from this side will be like this one. If you look at from this side view, this is front view I have shown you, and if you look at from side, so this will be your side view. So you will see a circle over here like this. Okay, so now you can understand it with this figure also. Okay, so here the force is 30 Newton. Now I was discussing very important thing, like I was discussing with you in physics, how to write the formulas. See, this tau is equals to RF. I'm directly writing this formula. Now what is this? This vector. What is this? R is this also position vector, this also vector, and this F, that's also force, that is also vector. So how can it be possible that you have vector and vector on both sides? It means this is a cross product. It means this is a cross product. This is R cross F. So you need to be particular about whether it is F cross R or R cross F. So it is R cross F. We know this formula already. So shall we start with this formula, or shall we start with this formula? So this is a question that comes through mind. Now here, this formula, the magnitude, see the vector, it has two things. One is the magnitude and another is the direction. So these are the two things. So magnitude is, what will the magnitude of this torque? Magnitude of R into magnitude of F into sine theta, and that's equals to R sine theta is your R perpendicular into F. And then the direction is, direction of tau is perpendicular to R, perpendicular to F, and perpendicular to the plane containing R and F vectors. See, that are the things that we know. So here, if I'm starting with this formula, this can only possible that this magnitude is this, and this R perpendicular means this magnitude is possible this if the theta is equals to 90 degree between R and F. So if I'm starting with this formula, it's obvious that theta is equals to 90 degree between R and F. So here you have your F, and this is the axis of rotation, and this is the point of application of force. So that is the position vector R. So here R, and the angle is 90 degree. So sine 90 is 1. And another thing is this R perpendicular. So the R perpendicular means draw a perpendicular from the axis of rotation on the line of action. This is the line of action, this force. So perpendicular on it, that's R. So students, in physics we start with the formula from here. We need not to write these things. So this is what I want to tell, that in future, even in higher classes, in 12th class, so if these things are there, if the angle is 90 degree, then we'll directly starting with this formula with the magnitude of torque. So magnitude of torque, and then the direction of torque, I already know that is perpendicular to R and F. If that is required, then I will tell. If it is not required, no need to tell. Is this clear? So be particular about it. Now suppose you further come across the formula. We will come across more formulas, then we'll discuss more. Now we have tau, two formulas of tau. One is its analog from the linear motion, that is I alpha, and another formula for tau is R into F, that is by definition, and that is from the linear part. We have derived this formula, right? But how to remember it? That's F is equals to ma by this formula. Okay, now we can equate these two formulas also. So I alpha is equals to RF, same we did in example 7.15, or you can put the value, you can calculate the tau from here, R into F, and put this value over here and divide it by I. So that's the same thing. So alpha is equals to r into f divided by I. So that's torque upon I, same thing. Okay, so here I have equated these two equations, so first and second. So same thing, students. So alpha is equals to what's your r? R is given to us, that is 0.4 meters. And what is F? Force is 30 newtons divided by moment of inertia mr square. So what is mr square? M is 3 kg mass and the radius is 0.4 square. So this comes out to be 0.48 kg meter square. So 40 upon, so radius is
force is 30 Newton.
30 Newton, yes. So force is 30 Newton. So this force is 30 Newton divided by the moment of inertia that we have calculated, 0.48. Okay. So calculating this comes out to be alpha is equals to 25. Now very important to write the units. So here the units of acceleration is meter per second square, right? So what will the acceleration? So here this here it was linear displacement and angular displacement. Angular displacement is measured in radians. So radians per second square. So that's the unit, radians per second square, angular acceleration. Now what is linear acceleration? So linear acceleration, see, acceleration is equals to dv by dt, and this is a linear acceleration, linear velocity. And now acceleration is equals to, in rotational motion, v is equals to r omega. See here also, like I was starting with this formula, so you are starting with this formula. Why? Because see, this is vector, this r is also vector, and omega is, this is a position vector. So all three of them are vectors. So it means there is a cross product, and I am writing only the magnitude. So cross product, it's sine theta, and the angle between r and omega is 90 degree. So students, here also it's 90 degree. So I need not to start with this formula, this omega cross r. I know this is not r cross omega, this omega cross r. But as I'm writing only magnitude, and sine is 90 degree, sine 90 is theta is 90 degree. So I can start with this formula, students. No need to start with this formula and telling the theta is 90. It's obvious theta is 90, so starting with this formula. So this is the difference, whether you shall start with vector formula or this. So if you are talking only about magnitude, you can start with this formula. So it's obvious if anywhere it is written in the book. So now you need not to get confused. Okay, so we can start with this formula like this. So that's r into omega. So a, this r is constant, will come outside, d omega by dt, and a is equals to r into, what is d omega by dt, like dv by dt. So that's d omega by dt is your acceleration, angular acceleration. So a is equals to r alpha, similarly like v is equals to r omega. So second part, b part of this question, linear acceleration is equals to r into alpha, and that's r, that r is equals to 0.40 meters. That's your r. And what's your alpha? Alpha you have just calculated 25. So that comes out to be 10 meter per second square. Okay, students. So now next question, next exercise 7.15. So we are doing revision also simultaneously. So here we have a motor, and this motor, so you have like, so you have this a motor over here, and this motor is rotating. Okay, this is the action, and uniform angular speed. So angular speed is 200 radians per second, and an engine needs to transmit a torque of 180 Newton meter. So what is the power required by the engine? And assume that the engine is 100% efficient. So means the power is transferred from this rotor to the engine. So 100% efficiency. So now here Students, one more thing I want to tell you that see, what are the units of forces? So unit of force is Newton. What are the units of torque? Its rotational counterpart. So that is rotational moment of forces, or torque, responsible for rotation motion. That's Newton meter, because tau is equals to RF. So F Newton R meter. So see, the units are also different. Okay. Now the power. How much the power required? Now what are the formulas of power? Power, you know, that is equals to instantaneous power. Average power is put a bar over here, dW by dt. Instantaneous power. Don't put a bar. Instantaneous, dW by dt. And if you put the value, what is dW by dt? That is Fs. So I'm writing here Fs. I know that's a dot product, F dot S, but I need only the magnitude. And here the theta between F and S is 0. So that is why cos 0 is 1. So this is now, students, you are supposed to be comfortable with. Okay? Directly writing the formulas without the dot product. So when there is dot product and theta is 0, directly write it. Directly write the magnitude. When it is a cross product and theta is 90, directly write it. Like I have written for this torque. So this is the cross product. Here theta is 90 degree between them. And it's a dot product. And here the theta is 0 degree between them. So that's a dot product. So cos 0 is 1. So Fs cos 0, cos 0 1. Got it, students? So in the books you will find the formulas directly written like this. W is equal to Fs. So it means that force and displacement are in same direction. And here this is your R and this is your F. Okay, so cross product angle, both the vectors perpendicular to each other, they get the maximum torque. So that's the maximum. So we write the maximum. So that's the maximum work is done if F and S are in same direction. So here the maximum is output is there for the dot product when both are in same direction. And here the maximum for the cross product if both are perpendicular to each other. Okay. Now what is force is constant. So because this work done is only for the constant force, otherwise the force is variable, then the work done is equals to integration F dot ds. So F and then ds by dt is your V. So again power is equals to Fv. So force is a vector quantity and this is also a vector, your velocity. So both are vector. So here it is actually so that's in the previous chapter, if you remember. Any of you can tell me the page number quickly, on which page number we have this formula? That's on page 129 in our NCERT books. So this is scalar and this is vector, this is also vector. So vector scalar. So vector, so it means it's a dot product. So F dot B. Okay. So but here as I told you that if the theta is 0 degree, then Fv cos 0 is 1. So we can directly write P is equals to Fv. Have you got it, students? You'll find this formula directly. Like K is equals to half mv square. Even this basic thing. The velocity is a vector. So K is scalar. So of course there is a dot product between V dot B. And of course the angle is 0 degree. So students, this was the important thing that I was supposed to tell you, how to write the formulas, dot product, cross product. Now I think whenever you will be formulas are there in the book, you know that for cross product angle is 90, we are directly multiplying the magnitudes, and in dot product the angle is 0 degree and we are directly multiplying the magnitude and getting the maximum physical quantity in both the cases. Okay. So like here P is equals to Fv, so its counterpart P is equals to in rotation motion, instead of F I have tau and instead of V I have omega. So P is equals to tau omega. So simply multiplying it. So you know this formula, so you need not to write this thing. This is just a sort of revision we are doing the whole revision of the mechanics. Chapter 6 is also revised, other chapters are also revising while doing this chapter. And students, so you need to be very particular about it. So 180 into 200. So this question was pretty simple, but we have revised the whole physics. So that's 36 kilowatt. Okay. So next question. That's 7.16. So here we have a uniform disk of radius r. So that's the center of the disk. That's, you can write O. Okay. Now a circular hole of radius r by 2 is cut out. So we have cut out a circular hole out of it, and the radius is r by 2, and the center of the hole is also at a distance r by 2 from the center of the original disk. So it means this distance is r by 2. So it means this circle is cut through this hole is cut through the one point here is O. So this center is at a distance r by 2, and radius is also r by 2. So that's the figure that we get. So you can write it as O1. Now so see students, when we had 2 point masses, even if there are two bodies, and first of all we find their center of masses. So this is the center of mass, and this was your point origin. Like, so you have two choices. This distance is your x1, this position is x1, and this position from here to here, that's x2. So this position x2, and this distance is x2, this distance x1. So we have to find the center of mass. So center of mass was located somewhere here, right? And but in example 7 points, so the formula for the center of mass is m1. So this is m1 and this is m2. So m1 x1 plus m2 x2 divided by m1 plus m2, right? But in example in exercise 7.2, we have seen that there was this hydrogen and this chlorine. So we assume the origin at H, so that at least my x1 will be 0, so that this term will be cancelled out. Okay, so that was for the when we had 2 point masses. Now but here in this question I am taking out this portion. So when you are taking out this portion, so then the formula that you can write is that this for the center of mass. So when you are cut a portion, okay, so then instead of plus here I will have minus. So because you are taking out that mass, so m1 x1 minus m2 x2 divided by m1 minus m2. So this mass you have taken out. Okay, so this one was your original, and this you have cut. Okay, so simple, you know the formula now. Now you can do it. So x equals to, in this case, what it comes out to be. So the means from where you are going to where will be the center of mass. So if this was the this was your earlier means disk, this disk is uniform, so this was the center of mass, the geometric center of the disk. But as I have removed this portion, so obviously the center of mass is going to shift to this side, and we have to find this distance. How much is this distance? Okay, let this point be O2. So this is the center of mass O2 of the portion, means new after removing this, so we are left with this part only. So O2 will be the center of mass, new center of mass. So that's what we are finding, this x. So this distance is the position from here, it is x. So obviously this answer is going to come out to be minus, because this is the sign conventions we are taking. So this, so from origin this is positive direction, so this is, but this is this side from the origin, so this will definitely be negative. Let us see, you'll get the negative x. Okay, so that's x. So the location of new center of mass, so that's x. So what was your original m1? So that's the mass of the body into x1. So x1 was over here, so the center of mass was at O only of the disk, so that is why the distance is 0. So same thing we did in exercise 7.2 also. And m2 now, and m2 into x2. So m2 into, what is x2? x2 is this distance, so this to this, so it's plus r by 2. Okay, so there's the portion that you have taken out. What is the center of mass of that portion? So that's the geometrical center of it, and that geometrical center is r by 2 distance from the origin. So m1 minus m2. Now students, in these questions, what is mass, what is density? And we have this disk, so it's area density basically, so surface density we can say. So surface density is sigma is equals to mass upon velocity. So that's mass upon area here, density is equals to mass upon volume, so that's volume density, and this is surface density. So when we have lamina or plate or disc, we take the thickness as negligible, and that's, so what is the mass? So mass is equals to density into area. So what's the mass here? So that is equals to density. So density is uniform into, so actually this portion gets cancelled out, 0 multiplied anything is 0. So let us write about m2, so that's minus density into area. So what's the area of this cut portion? That's the radius is r by 2, so pi r square, so pi into r by 2 whole square divided by, so this was 0. So that's equals to, so what is m1? So m1 is same, mass is equals to density into area. So density, this is the density. So we have to assume, let the density, let surface density is equals to nu. Okay, so this into area. So what was the original area? So that was pi r square, isn't it, minus this mass. So okay students, one thing we left, we have written this is the mass, that is density into area, right? But what about this r2? R2 is also there, we have forgotten to write this r2. So this is the mass, so directly this mass we can write over here. So nu into area is pi r by 2 whole square. Okay, so this comes out to be minus, so you can clearly see that sigma is there with all the three terms, so we can cancel out sigma, and pi is also there in all the terms. Okay, even r square is also there in all the terms. Okay, so this will be r square upon 4, right? So r square, this will be also r square by 4. So this is, so what you are left with, so this is 1 by 4 into r by 2 divided by, this is 1, so don't forget it students, this is 1, not 0. Here it was 0 because 0 multiplied anything was 0, so here it was 0, but here it is 1. So 1 minus, this is r square by 4, so this is 1 by 4. And what do you get from here? So that's minus r by 8 divided by 3 by 4. And this comes out to be minus r by 8. The reciprocal of 3 by 4 is 4 by 3. So that's equals to minus r by 6. So I was telling you that this x, the position of the new center of mass, will obviously be in this direction, and it is at a distance r by 6. So this is r by 6. This total is r by 2, and this is r by 6. So still 2/3 is left this side, and this is out of this total, this is 1/3, this is 2/3. Okay, so that's that was this question. Students, we have similar questions in IIT also. Okay, so this is the formula you need to use. There was similar question in 2020 in IIT. We don't have time actually, so this here instead of this there was this square and goodness. So but same formula, you'll get the answer for that one also. So next question, it is 7.17. So we have a meter stick, and that meter stick is balanced. Meter stick, name is meter, so stick like unit circle, so circle which has unit as radius, meter stick, so whose length is 1 meter. That is the meaning of meter stick. And it is balanced on a knife edge at the center, so it means it is uniform, the mass is uniformly distributed, uniform density. So this was the center of mass. But now what have we done? When two coins each of mass 5 kg are put one on top of the another at 12 centimeter mark, so what there are marking 0 and then 10 and then 20, here it is 50, and here the mark is 100. So where the mark at 12 centimeters, so that's 12 centimeter mark. So we have placed two coins of 5 kg and 5 kg, 5 grams and 5 grams, so total is 10 grams. And that's this distance is 12 centimeters, so 0.12 meter or 12 centimeter. The stick is found to be balanced at now the new center of mass. So this knife is supposed to be placed now at a distance. So earlier on, of course, it was at 0.5 meter, but now it is at 0.45 meter. This balanced. What is the mass of the meter stick? So we have to find the mass of the meter stick. So students, let us draw this sort of freeboard diagram here. So here we have the reaction. Okay, so that's the normal reaction we have over here, and we have weight over here. That's 5 into that's 10 grams. So here we have the weight, and then the mass of the rod is also there. So here, so this is the weight, these are the weight of the coins, and we have the mass of the rod over here. So that's the weight of the rod, because this is the center of gravity at this point, right? Balanced over here. So of course this is the center of gravity. This point is also center of gravity. You can call it center of mass also. See, in previous question also we were supposed to find the center of gravity, and we have found the center of mass. So here we have to write as so this is previous question, students. I've just remembered that in previous question it is actually it is center of gravity. So as G is uniform, so center of mass is same as center of gravity. Okay, so no problem whether you are supposed to find center of mass or center of gravity, because throughout the disk G is uniform. Okay, so yes, we can calculate it like that also. Otherwise, another way about the find equilibrium and then torque way, that is also there in the book in SLOD, but that's fine. Okay, now here we have this normal reaction, and due to this knife we have this normal reaction, and the weight is also there due to the center of gravity. Now Again we'll be taking the, so it is in equilibrium. So this rod, so its weight will be equals to the mass of the rod into g. Okay, and this see, you can solve this question in CGS system also by CGS or MKS, that's your choice. CGS means centimeter, grams and second, and MKS means meter, kilogram, second. But student, this is SI unit. This was the CGS unit, is no more. We use this system, but you can find the answer using this way also, through CGS also, but have a habit of finding it with MK system. Okay, so now here in MK system, this 10 grams will be equals to, so that's equals to 10 grams means 0.1 kilogram, right? 0.01 kilogram into g. Okay, so 0.01 into g, that is due to the coin, that is the weight of the coin. So this arrow should be very, means very small. This force is actually very small as compared to this is the mass of the rod. So this W is, this magnitude is very small as compared to this for the rod. Okay, and this for the coins which are placed over there. So weight of the coins, that is 0.01 into, so that's also m into g. So here is the mass of the rod, and here mass of the coins into acceleration due to gravity. Now students, it's equilibrium. So equilibrium condition, net torque is 0, and so we have two equilibriums. One is translational equilibrium, another is rotational equilibrium. So which equilibrium? So let us take the rotational equilibrium. So rotational equilibrium needs means net tau is equals to 0 and tau is equals to r into f. So we'll take the moments for equilibrium. So mg. So what's this distance? If we are taking it from the origin or taking it at g. So let us, if we take it at g, the advantage we have is that these two will be zero. So principle of moments for equilibrium here. So how much is this distance? So that there is one mistake that we are doing here, that I have placed this. See, what's the mistake I have done drawing this diagram? See, of course, the center of gravity of the rod was here. That was your weight, this weight of the rod. And this is where I place the knife, the place where the center of gravity of the new system. So because I have placed the coins over here, so as I place the coins over here, the center of gravity is shifted to this point. So now it is at a distance 0.45, right? But the weight of the rod remains at 0.15. So this distance, so center of gravity is shifted by a distance of 0.05 meter, or you can say 5 centimeter, because this is this distance is 0.45 meter. So the total was 0.5 meter, but as I place the coins over here, 2 coins, so now to balance this rod, so this is the center of gravity of the system, which contains coins and the rod, but here the weight of the rod will definitely be over here, that is the center of gravity of only rod, okay, and this G is the center of gravity of the system now, which is shifted by 0.5 meters to this side, from here to here to here. Okay, now let us take this rotational equilibrium. So net tau is equals to 0. So taking the moments about, where will be your axis, taking moments about, so it's better if you take the moments about your, so this was your earlier G dash you can say, and this is your new G, okay, new center of gravity, that's G. So taking moments about G, okay, so axis of rotation is over here, so if axis of rotation is over here, so due to this weight of the coins, it will tilt in this direction, right? This will tilt in this direction if I have only these coins. So that's the direction of tilting and direction of rotation. And now due to this and this direction, we know that the sign convention x, y, and this rotation of this direction we take positive. So that's the direction. This is positive, and then this is positive, and then this is positive. This is anti-clockwise direction. So this is also anti-clockwise. So that's positive. Now what about moment due to WR? So of course here due to WR also it will tilt downwards. So that's that's negative direction, which is clockwise. So taking moments about G. So this force is your WC, and the distance of this from this, how much is this distance, students? So this distance is 0.2 meters. So this distance is 0.45 minus 0.2 meters. So this comes out to be 0.33 meters, right? So because net torque is equals to 0, so torque due to this WC will be R into W. So torque is equals to R into F. So R here is 0.33 into the force, that is M into G, that is 0.01 into acceleration due to gravity. So that's R into F. F is your weight here, plus so what was sign here, plus. Now next, due to this this normal reaction. So normal reaction, so here the distance is 0 between the line of action and this origin. So 0, distance is 0, so R is 0 here. And what is the force here? Force was your N, right? And then this distance is, this direction is negative due to WR. So R and W here for the WR. So this was for WC. This is for WR, weight of the rod, and this was for the normal reaction due to the support. Okay, now this, what is R here? So R is this distance, that is 0.05. And what is the force here? That is the mass of the rod into acceleration due to gravity, into that's into 0. So net torque, rotational equilibrium, so net torque is 0. So net torque equals to 0. We can write this anti-clockwise is equals to clockwise torque. So this also can be written. So 0.33 into 0.01 G is equals to, this is 0, and this negative will become positive, that's 0.05 M into G. Okay, students, so this 2 decimal points, let us remove these two decimal points. So this G will also be cancelled out, and M comes out to be 33 into 0.01 divided by 5, and this mass comes out to be 0.066. So that's equals to 66 grams. So you can calculate it with centimeters also. you will, and Gram's CJ system like SL there he has done it, same answer you will get. Okay students, watch the videos again, okay, and so once, twice, yes, you need to put efforts definitely. So next question is 7.18. Students, this is 7.18 and we have question 7.27 also. So which is the same as example 7.16 in our books. So means masses are rolling down, okay, from the top, okay, in some so, and we have one more question, that is 7.21, where the mass is going up. So we'll do that question also today. So only two possible cases on the inclined plane. This angle is theta. So students, see, we have the derivation which is there. That's not part of our syllabus, but still because you need the derivation to do this exercise question 7.27, that is supplementary exercise. So the derivation is there in SL Aurora, page 7.49 and 7.50. If you are interested, you can do the derivation from there. And on 7.50 we have reached the formula that the acceleration, linear acceleration, is equals to g sine theta divided by 1 plus I upon mr square, and value of I you can put as 1 plus I is equals to, we can write it in the form of radius of gyration, that is k, so upon mr square. So mm cancels out, and this g sine theta upon 1 plus k square by r square. So students, that's your acceleration, linear acceleration, and we have derived the formula for the kinetic energy. Yes, that is there in our book. So formula for the kinetic energy we have derived, which is the rolling motion, page number 174 and 175 in our NCERT books. That is equals to rotational plus translational kinetic energy, and that total kinetic energy when it was coming down here, the total kinetic energy K is equals to half m omega square plus half m VCM square. So rotational plus translational, and then from this we derived the formula for the linear velocity also. So this is the formula for the linear acceleration, and this is the formula for the kinetic energy, and this is the formula for the velocity. So velocity is equals to, or v square is equals to 2gh upon 1 plus k square by r square. So these two formulas, this one and this one, is there in the NCERT, the derivation, and this derivation is there in SL Aurora. Okay, so students, what this question is about? This question is this figure we are discussing. A solid sphere. This is a solid sphere which rolls down along two different inclines. So what are these two different inclined planes? So one is this theta is only this much, and here the theta is more. So this theta 1, suppose this is theta 2. So theta 1 is greater than theta 2. So it is more inclined, right? So will it reach the bottom with the same speed or different speed? So here the speed is suppose v1, here the speed is v2. So where do you have more speed? Of course, yes, v1 or v2. Will you have same speed or different speed? Students, see, we go by not by heart but by mind here in physics. So see, this is the formula for v. Does it depends on theta? It only depends on h. See, this figure is actually this figure, I need to draw this again, because the height is supposed to be same. This height is supposed to be same. So this height is supposed to be same, but the angle can be lesser. Okay, this height is same, and sphere roll down from here and reaching here with this velocity v2. So this is theta 2. So this is greater, this is smaller. So height is same, acceleration due to gravity is same, k radius of gyration of the square is same, and the radius of the square of the sphere is also same. So obviously v is equals to under the root 2gh upon 1 plus k square by r square. So v does not depend on theta, inclination of the slope. So that is why v1 will be equals to v2. Velocity will be same in both the cases. Now the second part is, will it take longer to roll down from the plane? So see, as far as this longer thing is concerned, tell me that it obviously depends on the acceleration, isn't it? What it depends on? The velocity is same, linear velocity. But what about angular velocity? Do you think the angular velocity will also be same? Yes. So in which case we'll have more angular velocity. So where we will have more acceleration. So of course, in this case, acceleration is given by is equals to g sine theta by 1 plus k square by r square. So it means acceleration is directly proportional to sine theta, and sine theta is directly proportional to theta. So more is the theta, more is the value of sine theta, and more will be the acceleration. So acceleration is directly proportional to theta here. So more is the theta, more will be the linear acceleration. So here the linear acceleration is more in this case. So linear acceleration of linear acceleration will be more for where theta is more. So theta 1, so acceleration 1 will be greater than acceleration 2. Now what's the formula for acceleration? So we have acceleration, we just did, that is equals to r into alpha, right? We did it today, I think. A is equals to r alpha, because we know the formula for v is equals to r omega. So similarly we have a is equals to r alpha, we derived it today also. So a is directly proportional to alpha. So it means greater is a, greater will be the angular acceleration. So angular acceleration will be greater in this case, right? And greater will be the angular acceleration, greater will be your angular velocity, and lesser will be the time. So here this time will be greater. So in this case theta 2 time will be greater. So greater time in this case, because so time is greater in case of students. Understood this concept? Have you understood this concept? Here there is lesser angular acceleration, lesser angular velocity. So this angular velocity will be lesser and more time will be taken. Okay? So what's the reason, means why it is more time? So more time because a is directly proportional to sine theta. So that's, so I have explained the reasoning over here. This C part, this is so you have greater alpha, and so omega 1 will be greater than omega 2. So of course, if omega 2 is greater, students, what's the discussion over here? So is directly proportional to theta. So sphere will take long time when the inclination is smaller. Okay, so this case. Now 7.19, next question. So in 7.19 we have a hoop of radius 2 meters and weight is 100 kilograms. It rolls along a horizontal floor, so you can make it vertical, and this is your floor, that's 2 meter. It's moving in this direction, so that its center of mass has a speed of so velocity of center of mass, that is 20 centimeter per second. So that's equals to 0.2 meter per second. How much is the work has to be done to stop it? So work to stop, so definitely it is possessing kinetic energy, and the work done to stop it means the kinetic energy will be reduced to 0. So that's equals to work energy theorem. Work is equal to change in kinetic energy. And how much is the change in kinetic energy? So kinetic energy change is equals to final minus initial. Okay, and here the final is 0, so whatever be the change, that is let the final energy let the initial kinetic energy be minus be k. So ki is equals to k, and kf is equals to 0. So that's 0 minus k, so that's equals to minus k. So work done will be the change in kinetic energy, that is k. So let us find out how much is the k it is possessing over here. Yes, so total kinetic energy here, and you know total kinetic energy is equals to rotational kinetic energy. So rotational kinetic energy plus translational kinetic energy, and we have written their formula. So rotational half I omega square, translation half m velocity of center of mass square, and that's equals to, so in case of this hoop is sort of ring. Okay, so what's its inertia? That's mr square. So its inertia is mr square. That's table 7.1, formula number 1, into omega square. What is omega? So let us write it in terms of v. So v is equals to r omega, and omega is equals to v upon r. So v center of mass upon r is the radius, plus half. So let us write, if I am writing capital M here also we can write capital M and VCM square. So here we have this omega square, so this also square. So this r square will be cancelled out, and we are left with half m VCM square plus half m VCM square. So half plus half is 1, that is VCM square. So now let us put the value of so first of all always solve algebraically, okay, and then put the values at the end. Now what is mass? Mass is 100. What is velocity of center of mass? That is 0.2, that square, and you will get 4 joules. So 4 joule of the work needs to be done. Okay, so next question, that is 7.20. 20. So we have a oxygen molecule. So of course we have two atoms of oxygen, one here, and join them with their radius, and this is the perpendicular to it is their axis of rotation. So they are, so we have this kind of situation in next chapter also, two masses and then joined by rod, and then we are twisting them. Okay, so here this oxygen molecule, and the mass is equals to 5.30 into 10 raised to the minus 26 kilogram. This is the mass of the molecule, means both this mass of the system we can say. So this is the molecule. For molecule I am writing, so molecule mass is this, and moment of inertia. So molecular you can say the system. So system contains of two atoms, and the moment of inertia is also given to us, and that is 1.94 into 10 raised to the power minus 46 kilogram meter square. And axis I have told you, and suppose the mean speed of such a molecule in a gas is 500 meter per second, and the kinetic energy of the rotation is equals to 2/3 of the kinetic energy of the translation. Okay, so find the angular velocity of the molecule. So kinetic energy of rotation is 2/3, so put the values here. Kinetic energy of rotation we have just written, so half I omega square, that's 2/3 translational, half into mv square. So we write cm or doesn't write cm, it doesn't matter, because this is the velocity of the center of mass. Now half will cancels out. What's the value of I? So that's given to us. What we have to find? We have to find here omega, average angular velocity, and omega is equals to 2/3 mv square upon I and under the root. So simply put the values of 2/3 into mass is 5.30 into 10 to the minus 26 into velocity, that is 500 square. So this 500 square of course will come out of 500 and into divided by the moment of inertia, that is also given 1.94 into 10 to the minus 46. So calculate it, you get 6.75 into 10 to the power 12 radians per second. So angular velocity, radians per second. Next question. So I discussed with you that here, this is a question. So here this solid cylinder is going up. That's the case that we are going to do now. So 7.21. So this is our inclined plane. This is the case of solid cylinder, because this moment of inertia is different for hollow and solid cylinder even. So we have a cylinder over here and it is going up. This angle is theta, and now this angle is 30 degree, and at the bottom of the inclined plane the center of the mass of the cylinder has a speed of, so velocity of center of mass is 5 meter per second here at the bottom. Okay, when the cylinder was at bottom, how far will the cylinder go up the plane? So suppose it goes to this much of distance, suppose. So that's distance is displacement from here to here is s, and suppose this is height h. Okay, so this is what we need to calculate. How long will it take to return it to the bottom? So it has gone up and then its velocity becomes 0 and then it comes back. So this time I have to calculate and then multiply it with 2. Okay, so we can solve it in two ways, students. First as in SL order, and second as per the formulas that we just discussed above. So if with the formula you want to solve, then A is equals to, so you can see that its velocity is decreasing, right? So negative acceleration, so A is equals to g sine theta upon 1 plus k square by r square. See, what's the advantage of this linear acceleration? So linear acceleration means acceleration along the line. So this, assume this as motion in one direction. Assume this motion in one direction. That's line. So you can assume this surface as this. So this, the velocity here is 5. So of course now this acceleration is this. Okay, and here it stops. So this is motion in one direction, and this is your velocity, this is your acceleration. So same here. So what is the acceleration? So here g is equals to 9.8. What is sine theta? Sine 30. Sine 30 is 1 by 2 divided by 1 plus k square. So what's the value of k? So for solid cylinder, go to table 7.1. So students, you need to remember table 7.1. And in case of solid cylinder, you can see that moment of inertia for solid cylinder is equals to mr square by 2. That's half of the hollow. Okay, so that's equals to mk square. So what's the value of k square here? That's r square by 2. So r square by 2 divided by r square, right? So that's the value of k. So I is equals to the means whatever be the moment of inertia, and all the moment of inertia we can write as mk square, and we can find the value of k square that is used in this formula. So that's half r square by 2. So this r square is will cancels out, and you are left with minus 4.9 upon 1 plus 1 by 2. So 1 plus 1 by 2 is 1.5, and when we calculate it, we'll find that this is your acceleration. So you can write it in terms of 9.8 also. So in 9.8 terms, this is 9.8 into 1 by 2 divided by this 1 plus 1 by 2, that is 3 by 2. So this 2 will cancels out. So that is equals to minus 9.8 upon 3. So that's the same thing, whatever it is. That's meter per second square, because this is linear acceleration, not the angular one. Okay, now we have found the acceleration, but our ultimate target is to find the value of s and then the time. So we know a. Now what is so how do we finding the value of s? So v square minus u square is equals to 2as. So that's now v is final velocity will be 0 here, right? So this is your initial velocity of the center of mass, and final will be 0. So 0 minus u square is equals to 2 into a. This is the value of a that you have just calculated, minus 9.8 upon 3 you can take into the displacement. So instead of putting the values, let us solve it algebraically for s. So s is equals to, you know, that is equals to minus u square, because this term is this is 0. Sorry, this final velocity is 0. So this minus a square upon 2a minus u square upon 2a, and what is u square? That is given 5. So minus 5 square upon 2 into what is this? This minus 9.8 upon 3, or you can write this one also. But this expression is simpler. So negative negative cancels out, and this displacement comes out to be 3.83 meters. So it has gone up by distance of 3.83 meters, students. Okay, and now the time. So how much the time taken? V is equals to u plus at. So no rotational formula. Okay, so this we have used with the rotational concept. So this acceleration has the rotational thing, but that has been cancelled out due to this r square. K is equals to r square by 2. So now purely motion in one dimension, you can say. So upward also you can see this. So that's the motion in one dimension. We are doing it like that only. So this v will be 0, so this will be 0. So what will be a t? T is equals to minus, so this positive will become negative going this side and divided by a. So what is u? So minus u by a. So minus u by a, and what is the total time? So this is the time for upward motion, so same is the time for downward motion. Total time coming back, going up and then coming back, so total time will be twice of this time. Okay, up same time, down same time. So that's equals to minus 2 into u is 5, and this acceleration is minus 9.8 upon 3, and reciprocal of it is minus 3 into 9.8. So that is equals to 3.06. So what will the units? Second. Okay, students. So, and the other way, if you want to see, you can, the solution is there in the SL Aurora on page 7.73, the other way solution. Okay, and the important question here in the remaining questions, so as we are running out of time, and so that's all for today, students. But be with me, I want to discuss something with you.